Hi, we are going to factor a polynomial when we are given one factor of the polynomial. So here's the first one. We want to factor 2x cubed plus 15x squared plus 27x plus 5. We are given that 2x plus 5 is a factor. So what that means is we have 2x plus 5, and we want to try to figure out what we multiply to 2x plus 5 so that it equals this whole polynomial. So first, before we do that, let's talk about how we multiply two factors together to get a polynomial. And a lot of times we use the area model, we use the boxes. So let's just do an example of that first real quick. Let's say we're multiplying, let's say like 2x minus 3 times x squared plus 4x minus 10. So we would take the 2x minus 3, and this is one method of doing this, just to try to organize all these terms that need to be multiplied together, is we use, this is called the area model. And again, it just helps us organize everything that needs to be multiplied together. We would do x squared times 2x, put that in the first box, and just keep going through multiplying terms together. And this just helps us so we don't miss any terms, and it helps us combine like terms at the end. So we would have 2x cubed, because that's the only cubed term. It's really important to notice that the like terms, when we use this model, are diagonal to each other. So we have negative 3x squared plus positive 8x squared. And then the x terms, these are also diagonal to each other, negative 12x and negative 10x. And then we have the 30. So this is the polynomial we would get if we multiplied these two factors together. Okay, so back to the problem that we're given. We have this factor, 2x plus 5. We are trying to figure out what we multiply it by to get this whole product, this whole polynomial. So let's go through that. I'm going to erase all of this. Okay, so I have erased everything, and I'm going to go back to the problem we were given. We have 2x plus 5. We're trying to figure out, again, what we multiply 2x plus 5 by to equal this. So I'm going to use the area model. I'm going to put the factor I'm given along the side, and I'm going to start to draw boxes. And maybe I'm not sure how many boxes to make. I'll just go ahead and make the first column. I am trying to figure out what goes along the top to multiply to 2x plus 5 to get all of these terms, 2x cubed plus 15x squared, to get this whole thing, plus 27x plus 5. So I'm going to put the first term, 2x cubed, in the first box. And then I'm thinking, I want to know what that question mark is, that red question mark. I want to know what multiplies to 2x to get 2x cubed. It would be x squared. So 2x times x squared, 2x cubed. And I'm going to multiply x squared times 5 and just fill in this box underneath the 2x cubed, 5x squared. Okay, I'm going to go ahead and make another column. And I've basically taken care of this 2x cubed term. And now I want to look at 15x squared. Remember when I multiplied out two factors, the like terms were diagonal to each other. So these two boxes that I've just circled need to add up to 15x squared. I have 5x squared so far. I need to figure out what goes here to add to 5x squared to get 15x squared. And that would be 10x squared. And then I'm going to move up here, and I'm thinking what multiplies to 2x to get 10x squared. It would be a positive 5x. 5x times 2x, 10x squared. So now I'm going to do 5x times 5 to fill in that bottom box. Okay, and now these two boxes add up to 15x squared. That term is taken care of. So now I'm going to go on to the x terms, and I'm looking at 27x. I'm going to go ahead and draw more boxes. So again, I just kind of keep adding columns until I'm done. So I need the 25x and the box diagonal to it to add up to 27x. So I'm trying to figure out what goes here to add to 25x to get 27x, and that would be 2x. And then I'm going to move up here and figure out what multiplies to 2x to get 2x. That would just be 1. And then I'm going to multiply 1 times 5 to fill in this last box, 5. And I'm just double checking all my terms. I have the 2x cubed right here. And then my original has a 2x cubed. So that's perfect. There is 5x squared and 10x squared. So I have the 15x squared. There's a 25x and a 2x. That's 27x. And there's this 5 at the end. And that was a plus 5. I kind of covered up the plus sign. There's a positive 5 at the end, and I got a positive 5 in the box. So I'm going to write out what I have. We want to factor. The original problem is to factor. So we were already given 2x plus 5 as a factor. The other factor that multiplies to 2x plus 5 is x squared plus 5x plus 1. And then the last thing I want to do is look at this quadratic that I have and see if it could still be factored even more. So when the problem says to factor, we really want to factor completely, see if there's any more factors, any kind of way we can keep breaking this up. So this would mean I need to think of two numbers that would multiply to get 1 and add to get 5. And that's not possible. The only numbers that multiply to get 1 are 1 and 1. Those don't add to get 5. So this is just not factorable. So then this would be my final answer because I can't keep factoring anymore. All right, we're going to try another one. We're going to factor 3x cubed minus 4x squared minus 28x minus 16, and we're given that x plus 2 is a factor. So I'm going to use the same method. I'm going to start drawing some boxes. Again, maybe I'm not sure how many columns to make, so I'll just start with the first column. I'm going to put the factor that I'm given along the side. And then my whole goal is to figure out what goes up here to multiply to x plus 2 so that I get this whole polynomial. So I take the first term, 3x cubed, and I put it in the first box. And then now I'm trying to figure out what that red question mark is. I want to think of what multiplies to x to get 3x cubed. That would be 3x squared. And then I'm going to multiply 3x squared times 2 and fill that bottom box in. Okay, so I'm going to keep going. I'm going to add another column. In the polynomial, I need a negative 4x squared. So far, I have 6x squared. I need to think of what goes here, that's diagonal to it, that will add to 6x squared. So these two boxes combined will equal 4x squared. So I'm going to put negative 10x squared. Now 6x squared and negative 10x squared equal negative 4x squared. I'm thinking of what I would put up here to multiply to x to get negative 10x squared. I'll put negative 10x times x is negative 10x squared. And then I'm going to do negative 10x times 2 so I can fill in that bottom box. I'm going to add another column. And then I'm going to look at my x terms in the original polynomial. I want negative 28x. Right now I have negative 20x. I need to figure out what to put here so these boxes add up to negative 28x. I'm going to put negative 8x. Now those boxes add up to negative 28x. Then I'm going to go up here. I'm thinking of what I would put up on top to multiply to x to get negative 8x. And then I'm going to multiply the negative 8 times 2, negative 16. And I'm double checking that is the number I'm getting at the end, negative 16. So now I'm going to write out what I have. I was given x plus 2, and that multiplies to 3x squared minus 10x minus 8 to get this whole polynomial. So now I've factored the polynomial into two factors. I want to see if I can keep factoring it further. So I'm going to look at this. And the way I factor something like this, with this 3 in front, so this is A, B, C, these numbers. I put A times C on the top of this like X thing. So 3 times negative 8 is negative 24. This is A times C. And I'm going to put B on the bottom. And then now I'm thinking of two numbers. I'm trying to think of two numbers that would go on the sides right here that would multiply to get negative 24 and add to get negative 10. Negative 12 and 2. So negative 12 times 2 is negative 24, and negative 12 plus 2 is negative 10. And then the way I keep factoring is using this area model. So if you have some other method that you've been using to factor, that's totally fine. This is the way that I factor, and I think most of you have been taught to factor. I take the first term, 3x squared, and I put it in the first box. So that's the first term from here. I take the last term, negative 8, put it in the last box, and then I take these numbers, negative 12 and 2, put an x on them, and they go in here, these other boxes. And then I'm going to fill in the sides. And I'm basically just factoring out. So if I look at this first row, the 3x squared and the 2x, I'm trying to think of what I can factor out of those terms. And I'm going to put that on the side. Just x is the only thing I could factor out of 3x squared and 2x. They have an x in common. Then I'm going to look at this row, negative 12x and negative 8. Negative 4 goes into negative 12x and 8. Get rid of that circle and put the negative 4. So they both have a negative in common, and 4 is the biggest number that goes into 12 and 8. Now I'm going to look at this column and think of what those terms have in common that I can factor out. And then this column, what do 2x and negative 8 have in common that I can factor out? Okay, so 3x squared minus 10x minus 8 is 3x plus 2 and x minus 4. And I'm going to bring down this original factor, x plus 2. And now I have the whole thing all factored out. We're going to look at one more example. This time we're finding the roots. It doesn't say factor, it says find the roots, but we're going to use the same method. We have to factor first so that we can find the roots. Given that x equals 1 is a root. So I need to work backwards. If at the very end we get these factors, let's say there's 3 of them. Let's say that we can factor it all and we end up with 3 factors at the end. In order to get the roots, we set those equal to 0, and then we can solve for x. So it's saying at the end, one of our roots is 1. That means one of the factors had to have been x minus 1. So really we're given x minus 1 is a factor. So I'm going to start it off same way as the other problems. We're basically given x minus 1 is a factor. I'm going to use the area model and figure out what I multiply to x minus 1 to get x cubed, basically f of x cubed plus 3x squared minus 4. So I'm going to take the first term, x cubed, put it in the first box. I'm going to put x squared on top because that's what I would multiply to x to get x cubed. And then x squared times negative 1, negative x squared. I'm going to go to the next column. So I have the x cubed taken care of. Now I want 3x squared. I have a negative x squared. I need to figure out what goes in that box to add to negative x squared to get 3x squared. (4x squared). Now those boxes add together to get 3x squared. I'm going to go to the top, and I'm thinking of what to multiply to x to get 4x squared. It would be 4x. And 4x times negative 1, negative 4x. Okay, I'm looking at this box here, and I'm trying to add something to negative 4x to get, there's 0 x's in the original f of x. So f of x is x cubed plus 3x squared plus 0x minus 4. There's no x's. So this box that needs to add to negative 4x those boxes need to add up to just 0x. So then this would have to be positive 4x, negative 4x, and positive 4x. Now these add up to get 0x. So then on top, I'm going to put 4, because that's what you would multiply to x to get 4x. And then 4 times negative 1 is negative 4. And that's this last term here. So I'm just double checking I get this number at the end in my last box. Okay, so now I have x minus 1 times x squared plus 4x plus 4, and this can be factored. I'm thinking of two numbers that multiply to get 4 and add to get 4, and that would be 2 and 2. And I'm going to bring down the x minus 1. So I'm just going to copy that down here. I already have the x minus 1, x plus 2, and another x plus 2. Or we can write that as x minus 1 times x plus 2 squared. That would be the same thing. Since we have two x plus 2's multiplied together, we could just put squared. So I have the x equals 1. I'm trying to find the roots. That's what it was asking for. Find the roots. That means set all these factors equal to 0 and solve. So I have the x equals 1. I already had that from the very beginning. And then if I do x plus 2 equals 0, I get negative 2. And then I have another x plus 2 equals 0, so I just get another negative 2. Both of these factors have the same root of negative 2, so sometimes we just also maybe want to add that negative 2 has a multiplicity of 2. We don't have to put that, but that's just telling me that we had two factors that were the same. But basically our roots are 1 and negative 2. 1 and negative 2. Okay, here's some for you to try. You're going to pause, try these problems, and then when you press play, I'll go through them. Okay, let's do number 4. So x plus 5 is a factor. I'm going to put x plus 5. Let's say that you weren't sure what to do. You weren't sure where to start. So start now, and then once it's set up, you can pause and see if you can try that. So the first thing we do is put x plus 5 along the side, because that's the factor we're given. We take the first term and put it in the first box. And then you're trying to think of what goes up here to multiply to x to get x cubed. If you didn't try it yet, pause and then see if you can keep going. This number was x squared. Then we do x squared times 5, 5x squared. And then I want 5x squared to add to something to get 2x squared. Now on top, multiply to x would have to be negative 3x to get negative 3x squared. Negative 3x times 5, negative 15x. And then now I want negative 15x to add to something to get negative 19x. And then I'm going to put a negative 4 on top, because that's what you multiply to x to get negative 4x. And then negative 4 times 5, negative 20. and that's this last number at the end, so that's perfect. And we want to see if we can still factor. So we have, for our answer so far, x plus 5, x squared minus 3x minus 4. Can we still factor this? So two numbers that multiply to get negative 4 and add to get negative 3. And that is the answer. And you can always multiply all that back out just to double check and make sure that it equals this whole thing. All right, next one. 2x plus 1 is a factor, so I'm going to put that along the side. First term in the first box, 2x cubed. X squared is what I would multiply to 2x to get 2x cubed, and x squared times 1 is just x squared. I need x squared times something to add up to negative x squared. This would have to be negative x to multiply to 2x to get negative 2x squared, and then negative x times 1 is negative x. Add another column. I need negative x to add to something to get negative 13x. It would have to be negative 12x. Now these add together to get negative 13x. And then on the top, I'm thinking of what do I multiply to 2x to get negative 12x. And then negative 6 times 1 is negative 6, and that is the number that I get at the end. So now I have 2x plus 1 times what I just got up here at the top, x squared minus x minus 6. And can I keep factoring? Two numbers that multiply to get negative 6 and add to get negative 1. This will be x minus 3 times x plus 2. And the whole thing's factored. It's factored completely. That's it. One more that we're going to do. Okay, so this last one you had to find the roots, and you would do the same thing. You still need to factor first before you can find the roots. We are given that x equals 2 as a root. That means x minus 2 was a factor in order to get x equals 2 as a root. So at the end, if you're solving, you get x equals 2. We're trying to figure out what else x equals. But the step above that must have been that x minus 2 was a factor, and we need to figure out what the other factor or factors were so that we can find the rest of the roots. Okay, so I know x minus 2 is a factor. I'm going to take the first term of my polynomial, x cubed, put it in the first box. On top must be x squared, because that's what you multiply to x to get x cubed. X squared times negative 2 is negative 2x squared. I need to know what goes here to add to negative 2x squared. These need to add together to get 0x squared. In this original polynomial, there's a 1x cubed, no x squareds, so 0x squared, and then negative 12x and 16. So in this box, it needs to add to negative 2x squared to get 0x squared. So it would have to be positive 2x squared. So then on the top would be 2x to multiply to x to get 2x squared, and then 2x times negative 2, negative 4x. I'm looking at the next term. I want negative 12x, not negative 4x, so I need to think of what goes here to add to negative 4x to get negative 12x. Negative 8x. Now those add up to get negative 12x. And then on the top, to multiply to x to get negative 8x, negative 8. Negative 8 times negative 2 would be positive 16, and I do have a positive 16 at the end. That means what I have so far is x minus 2 times x squared plus 2x minus 8. Can this be factored? We need numbers that multiply to get negative 8 and add to get 2. So I'm going to do 4 times negative 2. Those multiply to get negative 8 and they add to get 2. So x plus 4, x minus 2, and I'm going to bring down the x minus 2. So that is here. So I already have 2 as the root. Negative 4 would be another root. And then another 2, which I don't need to put, I already have it. In fact, sometimes we put 2 has a multiplicity of 2. And if you don't put that, that's okay. So our zeros are 2, which we were already given, and negative 4 are our roots. Zeros is just another word for roots. So our roots are 2, which we were already given, and negative 4 was the other one.